Welcome, everyone. So in the assignment, as you know, we need to be using Git. And in order to use Git, we need to know how to use the terminal, also known as the command prompt. Now, some of you might be wondering, what is that and how do I get to it? Well, if you're on Linux, you probably already know. If you're using a Mac, just open up the application called Terminal, and you'll get this sort of pop-up. That will be your terminal window in which you can type commands. If you're using Windows, the way to get to the terminal, in Windows they call it the command prompt. It's the same thing. You can type CMD, it's the CMD application. You can run CMD, or you can search for the application CMD and open that up. But the problem is that the Windows version actually uses different commands from everyone else. They have their own sort of Windows commands that are different from the ones we use in Linux and Mac. And moving forward, as you guys start working in industry, you will most likely be using the Linux commands. And so just to get everyone on the same page, what I prefer you do if you're on a Windows machine is first install Git. When you install Git, you will get this thing called Git bash. Git bash is this terminal that you can open up in which you can then type Linux commands. Got it? So if you're on Windows, it doesn't matter what version you're on, just install Git, launch Git bash, and you will have the window, and now we're all in the same place. And then we'll all type commands the same way. Is that clear? Now, there is a link online. Zaruhi and Artur, can you guys stand up for a second? Go ahead, stand up, stand up. Let's give them a round of applause, first of all. Thank you guys so much. So these guys, they put up a tutorial for those of you who are Windows users to see how you can install Git bash. If you haven't done it already, you can follow the link, follow their tutorial. They have great screenshots and so on that show you exactly what to do and how to get there. So assuming you have gotten to a terminal or to a command prompt and it's up in front of you, what do we do? What commands do we have at our disposal? So today, let's begin by that. Let's begin by having a look at some of the commands that are available. So first, so this is what the Git bash window will look like if you're on Windows. And if you're on the Mac, well, it will probably look like this. Yeah, this one. It'll look like that, or some variant of what you're seeing here. But you know what? I have my own. I use iTerm. Again, same thing, right? All of these are just windows in which you can type commands. It's the same idea. So what commands do we have at our disposal? Well, the first command, and kind of the standard command that you have to know, is ls. ls will list the files and directories for you. So let me see if I can zoom in. So right now, I'm in my root directory. If I ls and I hit enter, you'll see here, I'll see all the directories and files that are inside of this directory, right? Next is cd. cd stands for change directory. So if I'm in here and I want to go into pictures, for example, I do cd space pictures. Now here's what's cool about it. You guys might have wondered, how did I type pictures so fast, right? I didn't do pictures, I did boop. So it turns out that as you're typing, if you just hit tab, it will try to autocomplete for you. Kind of a cool feature. So if I cd pictures, I'm now inside the pictures directory. So you guys can think of this as effectively a file browser, but instead of having sort of a graphical user interface with pictures of folders and things that you can double click on, instead you're typing commands and you're going into the directory, right? So in here, again, if I wanted to see the list of all the files or directories inside of pictures, what do I do? ls. Boom. And here are all my fancy pictures inside of my pictures directory, right? If I want to go back up the directory, I do cd space ... And now I'm back up. And now I can also clear, clear, and that clears the terminal for me, and I can keep going. That way, you eliminate clutter. So again, ls will list everything. cd is change directory. If I specify a name of a directory, it will go into that directory. If I cd space ... it will go up back one. Is that clear? Okay, so now you all know how to navigate through your directory hierarchy, right? So no matter where you are, you can just ls to see the list of files and folders in that directory. You can cd into a directory, or you can cd ... back. Simple, yes? Good. By the way, for those of you who are on Windows, what might make sense is for you, when you're creating your projects, is to cd ... all the way back until you get to your root directory. And what is usually the root directory inside of Windows?
C drive.
C, yeah. So you go all the way back until you're in your C drive. And in there, you will make a directory, and I'll show you how to do that, maybe called projects. And you will put all your projects into that. And we'll discuss that in a second. So okay, so we learned ls to list the directories and cd to go back. I will usually not ask you to memorize things in this class. I don't really like to ask students to memorize things. I would prefer you guys just build things and do things, right? But these are things you just have to know, right? So the slide for this is up. Open it. If you don't know these commands, go in there and memorize them. There are like 8 or 10 of them. They're not that many. So the next one is mv. mv stands for move, right? So the idea is this. If you have a file in directory A and you want to move it, in other words, you want to remove it from this directory and put it into that directory, you can use this mv command. Now, in this homework, you're probably not going to have to use mv, so I'll skip it for now. But basically, with mv, you just give it the source, the starting point, what you want to move, and where you want to move it to. And you hit enter, and this will move here. Clear so far? You can also use move, by the way, to rename something. So for example, let me see. Oh, I have a foo.trig here, right? So that's a file. Can you guys see, by the way, in the back? Is the font too small? Okay, so let me rename foo.trig. What I'll do is mv to move it. Foo.trig is what I'm moving. And let me call it boros.trig. And now if I ls, there it is, boros.trig. And notice foo.trig is no longer there. Right? So I've moved it from one file to another, but by moving, I've removed it in one place and pushed it into another. But because I gave it a different name, I've effectively renamed it. Is that clear? You probably won't need move in any of the homework assignments that I give you, but because you can always actually open up your file browser and just drag and drop, right? But moving forward, as you do more and more work in this field, it's a good idea to know these things. So you might as well learn it now. Okay, so let's keep working. Clear to clear, right? What else do we have? We have man. So man is an awesome command. If you don't know how to use a command, man will tell you. Man stands for manual. So for example, mv. I want to know how to use mv. I type man, mv. There it is. And this is the description of what it is, how it works, what flags it has, what are the arguments that it takes. You read it, you go, oh, this is amazing, I know exactly how to use it. Then you hit Q to exit. That's it. Q for quit. Yeah? Simple. Again, I want to know how to use ls. Man, ls. There it is. You mouse down, or you hit the down button or up, right? You read it, you go, oh, good. And then you hit Q, out. Simple? Okay. So we got mv and man. CP. What do you think CP stands for? Copy. Yeah. I'll skip that one because you can theoretically, well, it works similar to move, right? Except that it doesn't remove the first one. It keeps the first one. It just makes the second. Cat is an interesting one. So cat, if you have a text file, maybe a JavaScript file, which is actually text underneath, and you want to see it, you can just write cat and then the name of the file, and the file will just print inside of your console. Right? So it's a way of quickly looking at inside the file. Kind of useful. Let me have a look here. So I think I had boros, right? So let me cat boros. Cat boros. Yeah. So boros is a file that has all this craziness in it. But there it is, right? So I can quickly look to see what's inside of boros. Cat. Okay? A few more. mkdir stands for make directory. Yes? Can you edit? No. So cat is read-only. If you want to go open up an editor inside of your window, you can use Vim or Nano or things. There are applications, but those are applications that you can run inside of your window. You can also just launch your file from within your thing as an actual like Windows application. I forgot what the command is for that, but just look it up if you're curious. Yeah? Other questions? Okay, so mkdir stands for make a directory. So let me, in here, suppose imagine I'm in my C drive. If you're using Mac, okay, imagine I'm in my root directory or whatever, or my home directory. So let me mkdir projects. Enter. Now if I ls, you'll see projects right there. It's a directory. I can go into that directory, right? So cd projects. It's empty. If I ls, I get nothing back because I just made a directory and it has nothing inside. What I might now do is do mkdir hello world. Now I have a hello world directory inside of my projects. I cd into hello world. There it is, and it's empty. And here is where I would now open up my file browser, go to that directory, and inside of that put in index.html. Put in my homework, all the things I need, right? Then do git init, which we'll get to soon, and then you do git push, which will be the hello world directory. I'll get to git in a moment, so don't worry if that didn't make sense to you. But the point is, do you know how to make directories? Mkdir, name of the directory. That's it. Cool. You can remove a directory. rmdir. rm generally stands for remove. If you want to remove a file, use rm. If you want to use a directory, you can do rmdir. You can also do rm to remove a directory, but you need to specify some flags. But don't worry about that. I'll keep it simple. Just remember rmdir to remove a directory and rm to remove a file. Rm, there it is. So let's go back here. So let me get rid of the hello world, right? So rmdir hello world. ls, no more. I've deleted it. Yeah? Okay, cd back to go back. ls to list the files and folders. Okay. What was I supposed to do? Oh, I was supposed to delete something. Okay, let me delete bolos. rm bolos. Enter. ls, no more bolos. Bolos is gone. Got it? Good. Clear. Okay, we have our, oh, clear you know, right? Clear just means clear the console, so it's nice and clean. Yeah? That's pretty much everything you need for now. There are lots of commands that you will need moving forward, not in this class, but just in the future, in your careers. But if you just memorize these simple ones, that's all you're going to need in this class. And that's actually enough to take care of you for even a couple of years, actually. So just memorize them, and you should be good. Any questions thus far regarding the terminal commands? This is fun? Okay. Again, obviously you don't remember these just now, right? Go home, open it up. There's a link to this. Read the descriptions. You can remember you can use man. So man rm, right? And then read about what rm is, how it works. Plus you have Google. So you can read tutorials if you like, right? Good. Okay, so now that we understand how to use the basic terminal, now let's talk about using Git, because Git is just another command within the terminal. Now there are graphical user interfaces, or GUIs. This is a fancy way of saying like windows and buttons and things, right? These do exist and it will help you work with Git. But for now, since you guys are just learning, I would rather you started off by learning this. Because once you know this, then you can move on and use fancy windows and buttons and drag and drop and that sort of thing. Okay? All right. So Git. Git.html. Okay, so the very first thing that you're going to do is go to GitHub. And in GitHub, on the top right, you will see like a plus button. If you click on the little blue thing, you'll get a few actions, right? New repository, whatever. Blah, blah. Click on new repository. Okay, this will create effectively a project for you in Git. You'll get a form, give it a name, something like Hello World or project number 1. I don't care what you call it. Call it Balls. Keep it public. So there's an option to make it private. Keep it public. Everything we do in this class will be public and made available to the entire world. Again, this will give you plenty of opportunity to embarrass yourselves if you do a bad job. Okay. So then, you finish filling out the form. You hit the big green button at the bottom to create the repository. And then it will navigate to a page with directions. I'll get back to that in a moment. So you do that first. Then what you want to do is actually make a project on your client, in your computer. Okay? So far you've made a project in GitHub, which is some remote server somewhere. But now you want to make a project on your computer. And a project is really a fancy way of just saying a directory. Okay? That's all it is. You're going to make a directory and you're going to put stuff in it. In the future, you'll put your index.html, your images, your CSS, you'll put all kinds of stuff in there. For this first assignment, all you need to do is put in one file, index.html. Right? That's it. So let's do that. So let's open up a terminal. Let me remove their projects just so we can start from the beginning. Okay, first thing, let me create a directory in which I'll put in all my projects, because this is not going to be my first project, right? Next week, I'm going to give you another project, and next week, I'm going to give you another project. So you want one place where you put all your stuff, right? So just for organizational reasons. So let me go ahead and make a directory called projects. Okay, there it is. Ta-da. Let me go into that directory. cd projects. Okay, it's empty, as expected. Now let me create a directory for this particular project. What do we want to call the first project? Make their first project. Okay, let me go to GitHub. There it is. Here are the directions I was mentioning. So directions that we're interested in are these ones here, which we'll get back to in just a moment. So let's go back. So far I've made a directory called first project. Let me go into that directory, cd first project. It's empty. I need to put an index.html into it, right? So one thing I can do, a very simple thing, is I can just open up my file browser. There it is. Go to, where is this? This would be in, what, users, Armenia. Is there projects in here? Projects, there it is. First project. And in here, I can now create a new file. So let me sublime. Hello world. Yay. This is going to be my HTML page. I'm going to save it. I'm going to save into index.html, and the location will be under users, Armenia, projects. Merci. Ta-da, save. Okay, so now if I go back to my terminal and I ls, there it is, index.html. Quick question, how can I right here in this terminal look at what's inside of index.html? Cat, yeah, watch this. Cat index.html. There it is, it's this right there. Okay, good. So now I have a directory inside of which I have index.html. Now what I need to do is I need to initialize Git. What is Git? Why are we even using Git? What's so special about Git? Well, imagine, for one, you write a whole bunch of really awesome code. And then you drop your laptop in the pool. An obvious problem right there, right? Okay, you've just lost all of your work. So what's one possible solution to that possible problem? Backup, yeah. So one way you could back up is maybe get an external drive, right, and constantly sort of copy into it, right? Although that requires some hardware. You have to sort of have it with you. You have to connect, and right? So there's that problem. Yeah, so you have to constantly back up, right? So in other words, you have to have your code somewhere else, copied somewhere else to keep your code safe. So that if one goes down, the other stays. Yeah? Okay, that's one. The second one, suppose you're working with other people, other team members, right? You're working on the same project. Well, one person makes a bunch of changes, and the other one makes a bunch of changes, and now there's a copy here and a copy there. What do? Do you like email them your code and then have them look at it and go, okay, now what do I do? And then maybe copy it over their code, and then maybe use some sort of a diffing tool to go through their code. And you understand the problem, right? There's an obvious complexity with working with other team members, which is that you're working on the same project. And so the question is, can you share this code somewhere? Can you keep it? Can you keep another replica of it, another copy of it somewhere else so that your code doesn't disappear if your computer breaks? So Git is one solution. So what Git will do is it's actually a peer-to-peer system. It's a node-to-node system. You have some code. You specify another server that also understands that code. In other words, you have the project here. You also have the project here. You can now, after you make changes, push your code, in other words, copy your code to that location. You can also copy your code to another location. Okay? Anyone else who has a copy of that can also push to that location. But if you've made a change, and someone else makes a change, what you can do is pull their changes, and it will only copy the parts that they've changed. If the parts that they've changed do not conflict with what you've done, they'll just get copied over, no problem. If there's a conflict, in other words, you modified the same thing that someone else modified, right, the same file, then there's a conflict, and it will tell you that. And then there are tools that will allow you to diff or compare just the changes in the files that have the conflict. You resolve these complications. In other words, you figure out which ones you want to keep, which ones you want to throw away. That's the merge. And then you push back. There are great tutorials, there are video tutorials actually online that you guys can watch to better understand Git and how it works. I don't want to have this become like a lecture about Git. But it's a very awesome system. And GitHub is just a website where they have Git. And so you as users can then use that to push your projects onto the site. And as long as your code is public, you can use it for free. They only charge you, I think, if you have private repositories. So only your team can see, but nobody else, that kind of thing. Okay so far? Okay, so far what we've done is we made a repository on GitHub. And we've made a project here. Now let's have a look at what the directions are that GitHub gave us. It first says echo. Echo means print. So this, you can forget about this part. This is basically saying print, for those of you who care, print this to your console, but pipe it or push it into a file called readme.md. In other words, it will make a file and it will push this into the file. We don't have to do this, so don't worry about it. The first thing we have to do is initialize Git. Okay? The way you initialize Git is by doing git init. Init for initialize. So inside of our project, we will initialize Git. Git init. There it is. It says initialized empty Git repo. Yay. Okay, done. That's it. So we've done the first thing. What's the second thing we need to do? We need to add, so here's the interesting part. Git has to know which files it needs to pay attention to. Okay? So you might have a directory with lots of files. Every time you want Git to pay attention, to look at one of the files, you have to add those files to Git. In this example, we need to add index.html, right? Well, this is the one that we care about. This is what we want to get uploaded. So we do git add index.html. Done. So that's the add. Commit. Commit is when you're ready to, it's when you're saying, I've done some work, let me commit it or sort of submit it to my local Git repository, So there, let me copy that, paste, done. That's it. I've committed it. Now, my local Git knows about index.html and has accepted the changes. Now we want to upload this stuff to GitHub, right? But how will my local Git know about GitHub? What address? Which project? Why GitHub? Why not something else? So what we have to do is we have to tell it about a remote location, a remote repository. So for that, we copy this. This is saying git remote, that is to say add a remote location, origin, which is just the name of the remote location, and then the URL that it gave me. So it will give you a different URL from the one it gives me, right? That's it. It now knows about the remote origin. Now, last thing is I have to do git push. Push is like upload. Yeah? Take my code and upload it. Origin means the location, because I might have multiple locations, right? So I'm saying specifically go to the origin location. Master is the branch. Don't worry about branches for now. We can maybe talk about it later. I don't want to give you too much right off the bat. So again, I copy that. I come here, paste, enter. It's asking for my GitHub username. I think it's rmestion. Password is, all right, I did the right password. And we're done. Now if I go to my GitHub, where's my GitHub? There it is. Ta-da! Here's my GitHub. There's my file. There's the comment that I put in saying this is my first commit. It will also say when I committed it, 2 minutes ago. I just committed it. Whatever. Anyway, the point is it's there, right? So it's under my username. I have a project called first project. Inside there's a index.html. Yay. Now, one thing. If you do decide to put into your project a readme.md, it will appear as the first page of your project. Generally speaking, it's a good idea to do this so that when people go to your project, they have something to look at. It's like a description of what you've done, right? A README is just, welcome to my project, here's how it works, here's how to run it, ta-da, right? That's all it is. You don't have to do it for the first project, but if you decide to, go for it. It'll just make your project more awesome. That's it. Easy, right? Right, so you can either do git add file A, git add file, or you can do git add like star, or git add dot, and it will add everything sort of in that directory, right? Git add dot. Yes, sir? You can, there's a command for that. I think it's, just like there's git add, I think there's git remove, or I can't remember off the top, but there is one, just Google it. Yes, you can do it. Yeah, okay, yeah. Yeah, so, right, so people can't, they can't modify it. They can't change your project right in your directory, but they can just download it, right? In fact, there's a, where is it? There's like a download button somewhere. I never use it because you always do git clone. The point is anyone, yes, anyone can read your code, anyone can, in fact, unless you go and remove your stuff, there is a high probability that in the future when you're going for a job, your employer will ask for your GitHub account. And the reason why they do this is to go and see what you've done. How does your code look? How clean do you write your code? How do you organize your code, etc. Right? So it's a good, so think of this as your portfolio. It's your public portfolio. It's like LinkedIn, right? In fact, have a reference from LinkedIn to your GitHub account so that when people read your resume, they now know where to go to read your code, which is really important if you're trying to become a programmer. Right? Other questions? Yes?
I pushed my project into GitHub already. As I didn't know about
What do you mean by manual? Oh, you mean you like uploaded the thing?
No.
How?
When I opened Git,
Yeah.
Git 3, I did browse,
Yeah.
and I put it in.
Oh, I see what you. Yeah, it's okay that you do that. I mean, you're not going to get penalized for it as far as grades are concerned. No, but just for yourself, just so you learn it, try to do this. You can do it and then delete it. It's okay. But just so you know what I mean. Just so you learn. Yeah. Other questions? Yes. So Git has this great feature where it never forgets your changes. So you're right, the latest change will be the new change, yeah. But you'll have a history of all of your changes. And the reason why it does this is because very often programmers make mistakes, right? And you want to be able to go back to sort of roll back, right? So Git has this feature where it keeps like the history of everything you've done. But yeah, but the latest one will be the last one you makes sense, right? Other questions?
You have a message.
Probably. Anything else? Is that okay? I have a message. Quit. All right. Good. Okay, so I guess let's get back to programming. Yes? No, just Google it. Google it. Other questions? That's it. The thing is, I don't want this to turn into like a big Git day. Git is something that there are so many tutorials about, and by the way, Git is not going to be on your quizzes. It's just, I want you to know it. So know it. All right, good. Imagine I want to make an HTML page, right? I open up Sublime, I'll make another one. And I say, hello class, yay. I want to save this. I save it, let's say on my desktop, and I call it hello c.html. .html is really important. The file extension is what will tell the operating system the kind of file that it is, right? So that when you double click on the file, it knows what to open it with. So I'll save. And now if I go, there it is, desktop, hello, where's hello C? Huh? Hello C. Ah, there it is, here it is, sorry. So if I double click, I get a browser with hello class, right? Now let me go back to this guy and add some JavaScript. How do I add JavaScript to an HTML file? Script tag. Script tag. And then in here, I write code like console.log, yay. And I save that. And if I go back here and I run it, I still get hello class. What happened to yay?
It's in the console.
It's in the console, right. So what I do is the simplest way, right click and go to inspect. And then go to console and you get yay, right? So now imagine this. Let me squeeze this down a bit. You see this, you have the editor here, you have the output of the HTML below it, and then the console log here. All I've done is I've taken that, and I've put it on my slide. That's it. That's all my slide is doing. So if I go here, where is it? Here it is. Look, if I write HTML here, hello class. Look, my HTML, and then my console, and my editor is here. Do you see how that is exactly the same as that?
How?
How? You gotta be me. No, I'm just kidding. No, it's actually very simple. It's very simple. So what I've done is, the thing is, if I explain it now, you have to know a bit of HTML, you have to know a bit more JavaScript, you have to know what iframes and things like that. Don't worry. Long story short, I've embedded a code mirror editor with an iframe underneath. If that made sense, great. If not, we'll talk later. But you guys understand, and the reason why I've put it on my slide is because it's much easier for me to show you on the slide than it is for me to open an editor, go to the browser, open an editor, go to the browser. Make sense? Okay. So that's it. That's all that is. And to answer, I believe, your question, notice that this is nothing more than an HTML page. I put in a script tag and I put in JavaScript. So for your homework, all you have to do is make, what is it, 2 variables, right? How do you make a variable? Const, I don't know, A, 1, another one, const B, 2. Let's do some math. Someone help me do some math. A times B, woo! Someone help me print C to the console. Woohoo! I just did your homework for you. All you have to do now is add a bit of HTML and CSS just to show me that you know some HTML, and you're done. And then do all the Git stuff I showed you. Good? Okay. Let's get back to our main discussion. Okay. So last time, hang on, let me drill in a bit. Is that good? Everyone, too big. It's never too big, man. All right, if it's too big, I'll make it smaller. Okay, so last time we discussed conditionals, right? So this is where in your code, you want to decide which part of your code you want to run. Do you want this to run or that to run? And you want to do this based on a condition or a question, if you will. So for example, let me give sort of a somewhat practical example. Let's give const age. Age. And let's just suppose that I am 26, because I'm so young. I'm not really 26. But let's pretend I am. Let's suppose now if age is less than 6. So what do you do when you're less than 6? Go to kindergarten? You are too young to go to school. All right. Else, if age is, now, in order to go to school, you typically have to be what age? 6 or higher, right? It's not like you become 7 and they kick you out. It's 6 or higher. Okay, so age has to be greater than or equal to 6. Okay, now technically there's no rule for this, but typically you don't see like, 90-year-olds going to school, right? So what's the usual, cutoff in school? The usual cutoff. Let's say 18, just to be fair to, I was 18 when I was in high school, so let's just say 18. Okay, so both of these conditions have to be true. And, right, so and age has to be less than or equal to 18. So in this case, you are just right for school. Yeah. Okay. Else, for all other cases, so if you're greater than, so if to get to here, you can't be less than 6. You can't be between ages 6 and 18 inclusively. So you must be how old? What ages will go into the else? Greater than what? 18, right. Right? Because if you're 18 or less, but greater than or equal to 6, you'll be here. If you're less than 6, you'll be here. Therefore, everything else ends up here, right? So you have to be 19 or up to be here, right? So let's console log. Console log. Yay, you are an adult. If I change my age to 3, if I change my age to 18, yes. Okay? Conditionals, they're great. Okay, so now we understand conditionals, right? These if statements that decide whether we should execute this code, or that code, or that code, blah, 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 blah. Remember that we can also nest conditionals. So we can say, for example, yes, we can go to school if we're between 6 and 18 inclusively, but do we go to like middle school or high school or grammar school? Well, that also might depend on our age. So we can say if, so I don't know, what's like the first, how many years is like the first school you go to?
4.
4? Okay. So 4, so let's see. So if your age is greater than or equal to 6, and what?
Less than equal.
Right? Or what if I didn't want to use 10? I wanted to use 9. Sorry. Yeah. Or, wait, 10? Less than or equal to 10?
Yes.
Okay. Okay, then console.log, you are in the elementary school. Okay. Else if your age is greater than 10, I could also have done greater than or equal to 11, right? Same logic. So greater than 10 and, let's remember,
Less than or
less than or equal to 15, okay? Where are they now? You are in middle school. Okay? Do I need to write the third case? No, because it's else, right? It's all other. If you're not in here and you're not in here, then you must be in the third one. So you must be console.log. You are in high school. Da-da. I should probably get rid of my Facebook. Okay, good. Leave, yes. Okay, and it turns out if I am age, give me an age. 13. Not just.
No, not just. You are right for school.
You are just right for school and you are in middle school. Very nice. And if I change it to 5. You're too young. What if I change it to 8? You're just right for school. You're in elementary school. Very nice. Simple, right? Good. Okay. After condition, so we studied variables, which is basically giving a value a name, right? And the values that we've studied up until this point are, give me some values. Numbers.
Strings.
Strings, right? Text, strings.
Booleans.
Booleans, true or false. Good. There's another number. There's another value. Yeah, functions. Functions are values. Just like you can put a number inside a variable, you can put a function inside a variable, right? In fact, let's do that. So, and what are functions? What are functions? Yeah, you.
Functions are the place where codes are saved, and
Uh-huh.
when we type it, the code will run, and it will
Yeah.
open up and it will run.
Excellent. That's beautiful. Exactly. Yes. A function is nothing more than a piece of code that you can call and it will run. Very nice. Very simple. That's all a function is. So let's create a function. What is the syntax for creating a my happy func is what I'm going to call it. Inside of that, I'm going to put a function. How do I create a function? Other than you, anyone else? All right, parentheses is what they're called. Then I need a starting point, the place to start putting my code inside the function, and somewhere where I can say, here's where the function ends. How do I specify in this programming language a start and end? It's called a curly brace, for those of you who care. This is an open curly brace, and this is a closed curly brace. One more thing that I'm missing. Semicolon. Just like here, const A, I put a number, semicolon, or I do const B and I put a boolean, true, semicolon, or I do a const C and I put text, semicolon. In the same way, const D function, semicolon. Same syntax. Yes? Good. So I have a function. I want this function to print to my console, AUA rocks. What do I do? Huh? Okay. Console.log AUA rocks. With quotes. Very good. Okay. Right. So what I've done up until this point is I've made a function that has some code in it. That's all. What I now need to do is tell the function to run. Right? I need to execute the function. I need to call the function. Think of a function as this thing over there. I need to be like, hey, run. And it goes, okay, and it runs. Okay. So how do I call the function? My happy func. So I have to refer to it, right? And I call it. Boom. There. I want to call it again. I want to call it again. And again. And again. There it is, right? I can call this function as many times as I like. Kind of cool. Okay. So now I want the function, when I call it, to take some parameters. In other words, think of it this way. Imagine a function is like a builder. And I say, hey, build me a house. Build me a house. And the builder goes, how big? Well, I have to tell it, right? Well, I don't know, about, yeah, right? So I have to say whatever number of meters, right? So I have to give that function some value, some information, some inputs for it to then figure out how it should do its job. Make sense? So the question is, how do I give it these values? Anyone? How can I give the function values? Yeah, put it in the brackets. Wow, you've done some programming before. Okay. So I put a variable in the brackets. So how many values do I want to give a function? Two. A and B. Okay, good. Now it takes A and B. Now if I call it, it will still do the same thing. Why? Because what is the value? What have I given the function here?
Nothing.
Nothing. I've given it no input. In other words, I said, hey, run, but I didn't give it any inputs. Which is why the value for A and the value for B when it runs are nothing. And what is nothing? Undefined. Good. Now let me give it values like 3 and 4. Now what is the value for A when it runs and the value for B when it runs?
3, 4.
Right, so this 3 goes into that A, 4 goes into B. Good? So now instead of just saying AUA rocks, let me now concatenate that with the addition of A plus B. And now I get 7. What can I do now without modifying this code here? What can I do here to have the output be AUA rocks 100?
50 plus 50.
So 50 plus 50?
No, 50.
50 and 50. There. So without modifying the code that I've written here, I changed the behavior by changing the inputs. Which is kind of like, again, the builder. Depending on the size I give it, he will build me a big house or a small house, right? But the procedure for building a house might stay somewhat same. Right? The code stays the same, the inputs change. Good. Now, in the same way that we call a function and we give it some values as inputs, we want the function to give us a result, to give us an answer. How does it return to us a value? Very nice. So let's get rid of this for a moment. And instead, let's return the sum or the addition of A and B. Nothing happened. Why? Right. Actually, something did happen. It did exactly what it needed to do. It called here, it added a plus b, and it returned the value. It didn't print anything to the screen, it just, or to the console, it just did an addition.
Put it in console log.
Very nice. I can take this whole thing and do console.log, the result of it. Now think of it this way. When this runs, what does it return? 100. Actually, yeah, right, 100. So that's the same as that. This turns into this. Get it? That turns into that. Still get it? Good. Now, let me create another variable, const zoo, and let me call my what is it? No, it's a 2. Let me call it with 4 and a 5. Console.log zoo times 2. No one in the front row. Bless you. Oh, someone raised their hand. Go for it, man. 18. Okay, so let's break this problem down into parts. What is the value of zoo? Well, 4 plus 5 is 9. So this turns into 9. So zoo has a value of 9. And 9 times 2 is, of course, 18. Again, if you notice the steps that I'm taking as I explain it, I break the problem down, right? I solve it one piece at a time. Remember that. Okay, good. So you guys got functions?
Yes.
Is anyone confused by any of this? I'm looking at you, first timer. This is okay? Or you're lost? You can say you're lost, it's okay. Okay, so let's get complicated. Nah, I'm kidding, we never get complicated. Everything we do here is computer science is easy when you know what you're doing. Okay, so now let's do this. Again, let me go back to this example of console.log 1. And actually, don't I have an example of this? Hang on. Functions. Okay, there. So I want to do this. I want to be able to print between 1 and 10. This is one way to do it, right? We've had this example last time, but I want to cover it just one more time because it was like the last 2 minutes we did this. So this is one way to do it. But a better way might be to instead put this into a function. So const func. And put a console.log some number, n, which will be passed to it, m. And now we can call func1, etc., etc. I'm going to get rid of this. Right. And then I can just keep calling func3, func4, func5, etc., all the way until I get to 10, right? But that's not a great way. That's a lot of code. Suppose I then asked you to go to 100 or maybe more, right? You can imagine this doesn't scale. You can't just sit there and just type, right? So what's a smarter way to do this? Well, one way to do this is to just call the function one time, like that. Then what we will do, let me introduce a syntax error. What we will do is we will have the function call itself. Func n plus 1. So in this case, here's what happens. We begin by passing function 1, right? So n gets a value of 1. We print 1. So far, so good. Then we call the function again with n plus 1, which is 2, right? Because 1 plus 1 is 2. Good. So then we come here, now n is 2. We print 2. Then we get n plus 1, which is, we come in here again. N is now 3. We print 3, 4, 5, 6, 7. According to this code, when should the program stop? Never, right? This is theoretically what's known as an infinite loop. Okay? It's a cycle that doesn't have any logic to say that's enough, stop. There's a great joke, by the way. In shampoo bottles, do you know why a lot of computer scientists are bald? They don't have hair? Because the shampoo bottle says, wash, rinse, and repeat. It's infinite. Obviously, yes, the shampoo is eventually going to run out. That's the term. But anyway, it's a bad joke. OK. All right, so this will theoretically run forever, right? And can anyone guess what will happen to my browser if I fix this? There's a syntax error, right? If I fix it, yeah, it'll freeze, right? It'll say, and then it'll eventually show a window saying, do you want to like kill the script? Do you want to stop it? And then you have the option to do whatever you like. OK, good. So what we need then, if you think about it, is some code, some logic, to say that's enough, to say stop, right? So what we want to do is say, well, remember, I'm asking you to print between 1 and 10, right? Well, the starting point is 1. We know that. Fine. We come here, n is 1, we print, then n plus 1 is 2, we print, and we keep doing this. And when do we want to stop? Yeah, so basically we want to keep doing this until n gets to 10, or until n gets to 11 and then do nothing. Or you can construct your if statement however you like, but the main thing is we have to look at n. And if n gets too big, we have to stop. That's the idea. So let's put that condition in here. We can say, as long as if n is less than or equal to 10, then and only then run this code. Right? Remember, for the if statement, this is the starting point, this is the ending point. And this is the condition. If the condition is true, this code will run. If the condition is false, it will skip and stop. Nothing more to do. And the function will end, and then your code will continue executing after. Let's try it. Let me close this up. Boom, 1 to 10. Now suppose I asked you, you know what? Do 1 to 100. What do we have to modify here?
The 10.
The 10. We just say instead of running to 10, let's run to 100. And now we get doom, 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 doom. There it is. Make sense? Good. The term for this idea of a function calling itself in order to produce a cycle, is known as recursion. It's a scary, fancy word that they typically teach you much later, but it's so easy, I figured I would start with like the 3rd class. Right? Last time was the 3rd class, yeah? So you guys can tell all your programmer friends, we learned recursion 3rd day. Gangster. Right? Thug life. Yeah. OK, good. OK, oh, here's one. Suppose I wanted to print not from 1 to 100, but from 50 to 100. Huh? OK. OK, let's debug in order to understand exactly how this works. And that will so you will better understand what modification needs to be made. How do I debug? I create a breakpoint by writing debugger. I then hang on, let me get rid of the selection. OK, I now inspect element, and I get this fancy, crazy looking thing. And then I'm just going to run the code. So in your case, if you just have an HTML page, just refresh the page, right? F5 or whatever you use to refresh the page, and it will run. So I will just do that. Boom, there it is. OK, so in this line of, hang on, let me make this bigger. 1 second. Ooh, internet. OK, hang on, I made it too big. 1 second. OK, hang on. Can everyone read this code? Got people in the back. You can read this code? Yes. Those of you who are not sleeping. All right, good. Okay, so the first line will create a function and put that function into a variable called func. That's the name of the variable, right? In other words, I made a function and I gave it a name called func. Why do I give things names? Why do you have a name? Think about it. Why do you have a name? So people can refer to you. So if I say Pohos, you know I'm talking to you, right? Same thing. You give a function a name so you can refer to that function. It's that simple. Suppose you have 100 functions, right? Each one has a name. You now can refer to each one by its name. Make sense? Good. Okay, so now look, I'm calling func with 1, right? Let's step into that function by clicking the down arrow. N is now 1. It will ask, is n less than or equal to 100? Is this true? Yes, which means if I hit next, it will go inside and log n. In other words, it will print 1. We then do n plus 1, and we go into that function again. N is now 2. Is n less than or equal to 100? Yes, it is. We print it, and we add n again. And we keep doing this. I'm not going to do this 100 times, but you get it, right? It will do this 100 times, and only in the 101th time, the if statement will be false, and it will skip, and that will be it. The function will finish. Is that clear? Okay, well, if that's clear, let me ask you again. What's the first thing that happened? Let me run this one more time. So after we make a function, we pass a 1. It then prints. So now let's go back to my question. I don't want to do 1 to 100. I want to do 50 to 100.
1 with 50.
John. Exactly. Replace 1 with 50. So the first thing you print is 50. Then you add 1, which becomes 51. You call the function with 51. You print 51. Add 1, get 52. And you keep looping. So you started with 50 going to 100. So let's change that to 50. Boom, there it is. See, 50 all the way to something, to 100. Is that clear? Okay. Really? Okay. You sure? I'm impressed. Fine. Console. Okay. If you know the answer, just raise your hand. A few people are confused. It's a trick question. Yes, sir. Yeah, you. Which is? Very good. Now explain why. That's right. Very good. Okay, so here's what's happening, right? We're declaring a function. We're declaring a function. We call f with 1. So we come here, and a is now 1. We then call f2, passing in a, which is 1, and a 2. f2 takes nothing, returns nothing, and therefore the result of this expression is what this returns, which is nothing. Therefore, this returns the nothing, and that nothing is then put into C. And then the nothing is printed to the console. Good. Now, raise your hands. Yes, sir. You think it will give an error? Good, that's one. Armen, go. Huh? You think it's 2? Good? Yes.
1.
1, yes.
Undefined because it takes only undefined because it takes only one value.
Undefined, it takes one value. Yes, sir. Undefined. Okay, so we got, oh, are there other answers that are different from what have been given? Yes. 5, yes. Nan, yes. 42. John, I like it. This is great. We have more? Do we have more? This is awesome. But define me. I should have put this on the board with like scores on it and stuff. Okay. What's a good way to understand this code? One, good, yeah, but and how can we see what's happening? Debugger. Use a debugger. Use a debugger. Debugger. All right, good. So we open up a debugger. Okay. Let's see exactly what's happening. We create a function and put it into F2, or we name it F2. We create another function. We name it F. We call F with a 1. Let's step inside to see what happens. A is now 1, yes? We now call F2 with A, which is 1, and a 2. Let's step inside. Zoo is now 1. Zoo times 2 is 2. So in your head, replace this whole thing with a 2. So we return 2, yes? So this function now is going to return 2. Once it returned, the result of this was returned. If this returned 2, then this whole thing replaced with a 2, we return 2. Huh? Good. So then if this returned 2, then this replaces with a 2. Then that 2 goes into C, and then we print C. Watch. C now has a value of 2, which we print, and we get 2. Ta-da! Yes, sir.
We gave 2 values to function. Why did it take 8?
We gave 2 values. It ignored it.
It takes only the first one?
Yeah. So you're right. So we could have done zoo2, right? But am I using zoo2 in here? No, which is why it doesn't matter. If okay, now the next question, of course, is that, let's see, let's do order of operations. You guys are good at math. Hang on, let me change the numbers a bit just so they're a bit more interesting. Okay, go.
7.
We got a 7. Anything else?
7.
Oh, come on. Last time was so much fun. 7? That's all you got? Huh? All right. So let's have a look. So the answer is, in fact, 7. Okay, good. Let's have a look to see exactly what's happening. Let me open up command line, or the debugger. Okay. Quick thing, the debugger is super useful. If you can't figure out how to use it or you get stuck, come to office hours. Okay, the debugger will save you. I'm telling you. You have to learn to use a debugger. I use it all the time. Okay, so we create a function, we make a function. We call a function f with a 1. A now has a 1, we call f2 with 1 and 5, right? We step in. So now zoo has a value of 1, zoo2 has a value of 5, right? This 5 went here, and this a, which was 1, went there. Yes? We then, zoo2 plus zoo, well, because we know math, we know we multiply first, right? So zoo, which is 5 times 2 is 10. 10 plus 1 is, wait.
The other way. 1 times 2 is 2.
Right, 1 times 2 is 2, plus 5 is 7, right? So then we return that value, which is 7. When that value is returned, this whole thing turns to 7, right? Once it runs, it returns 7, so it's 7. That's the output. So this function, f, is going to return that value, which is 7. And so c takes the 7, and then we print c, which is why we get 7 at the end. Okay, now let's do this. Ooh, boop. What's the answer now? 21. Well, so we know that the result of this expression, because we're still passing in 1 here, this is 1, the result of passing 1 and 5 to f2 is going to return 7. We know this. We just did it. So 7 goes into z. 3 goes into z2, and we return the multiplication of z and z2. 3 times 7 is 21. Therefore, we return 21, assign it to c, and then print c. Okay. Any questions so far? Is this super simple? Yes. No. Yes. Who's saying no? Who said no? No, it's okay if this is not. This is actually, a lot of people don't get this. Okay, good. 2 people, good. 3 people. I like the, see, you're finally coming out. 4 people. Keep going. Anyone else? Remember this one thing, guys, and this is especially when I say ask questions. Even if you think, oh my God, everyone around me knows everything and I don't understand this, so I'm too shy. And any question you have, I guarantee you, out of all these people, there's at least one other person who has the same question in their head, and they're not asking. So if there's anything you don't, remember this one thing. If you don't understand something, it's my fault. It's not because you're dumb, or it's my fault. If I can't explain it to you, I'm the problem, not you. So if you don't understand something, demand it. Ruben, do it again. Explain. And I'll keep explaining it until you figure it out. And if I can't, we'll go to office hours, or I'll figure something out. Any professor that makes you feel dumb when you ask a question is a bad professor. Any professor. It doesn't matter where they are, whether at their AUA or, it doesn't matter. Any professor that embarrasses you if you ask a question is a jerk. Leave the class if you can, right? Because it's okay. We're in a learning environment. If you don't understand something, ask. I'm happy to explain it. Yeah? So, having heard that lecture, questions? Fine. Okay. Let's keep going. So, you guys understand functions? Sort of. Okay, let me throw something at you. Let me create a function. So remember that functions are values. Yeah. Ooh, wow. This is a great time to stop. Thank you so much. Wait. All right, for people on the sides, can you like come in? Because last time I took it, people were cropped off. All right. Oh, one second. This is a problem. Oh, stand by. Heartsoak of Cannon! Jan, merci, chat, bravo.